Quantum mechanics is a way of determining the orbitals or the wave functions that electrons can occupy. There are 4 quantum numbers that tell us everything we need to know about any given electron in an atom. They are n. This is Bohr's principal quantum number. L, the angular momentum quantum number, also known as the azimuthal quantum number. M sub L, the magnetic quantum number, and M sub S, the spin quantum number. Each quantum number has a set of rules, and it depends on the previous quantum number. N has the highest priority, then L, then M sub L, then M sub S. So there's a hierarchy. What N tells us is the main energy level of an electron. An electron at n equals 2 is at a higher energy than an electron at n equals 1. The allowed values of n are any positive integer. So 1, 2, 3, 4, 5, all the way up in principle to infinity. What L tells us is the type of orbital that we're dealing with. And that corresponds to the value of L. Now, L values can be any integer from n minus 1 to, from 0 to n minus 1. So 0 is the lowest possible value of L, 1, 2, 3, and the top is n minus 1. So, say you have n equals 3, then the possible L values are 0, 1, and 2. What these L values mean is the type of orbital. For L equals 0, you have an s orbital. For L equals 1, you have a p orbital. For L equals 2, you have a d orbital. And for L equals 3, you have an f orbital. Each of these orbitals, s, p, d, and f, has a different shape, and they get more complicated as the L value increases. The simplest is S, that's spherical, then P, which is shaped like a dumbbell, then D, which is like 2 p orbitals on top of each other, then F, which is something that has something like 8 lobes and is very hard to draw. What the magnetic quantum number tells us is the spatial orientation of the orbital. The possible values of the magnetic quantum number, M sub L, depend on the value of L that you're dealing with. M sub L can have any integer value from negative L all the way up to positive L. So the lowest value of M sub L for a given L value is negative L, then negative L plus 1, all the way up to positive L. This means that, say you have L equals 1, then your M sub L values are negative 1, 0, and 1. When L equals 2, your M sub L values are negative 2, negative 1, 0, 1, and 2. When L equals 3, your M sub L values are -3, -2, -1, 0, 1, 2, and 3. Now, this tells us something about how many orbitals there are in each sublevel. At L equals 1, we're talking about a p sublevel. There are 3 M sub L values. That means there are 3 p orbitals in a p sublevel. When L equals 2, there are 5 values. That's a d sublevel. And that means we've got 5 orbitals in a d sublevel. When L equals 3, that is an f sublevel. And look, 1, 2, 3, 4, 5, 6, 7 values. That means there are 7 orbitals in an f sublevel. And of course, when L equals 0, that's an s sublevel. The only value of M sub L is 0. That means there is 1 orbital in an s sublevel. The M sub s quantum number is spin, and this is really easy. For a single electron, it can be spin up, symbolized by an up half arrow. That's M sub s equals plus 1/2. Or the electron can be spin down, symbolized by this half arrow. That's M sub s equals -1/2. So at least there's one really easy quantum number. Now let's look at some of the consequences of these quantum numbers. When n equals 1, that means L equals 0 and M sub s equals 0. L equals 0 means an s sublevel. M sub s equals 0 means there is 1 orbital. This is a representation of the 1s orbital. Its shape is spherical. It only has 1 lobe. Now let's look at principal quantum level n equals 2. At n equals 2, we have 2 possible L values, 0 and 1. Remember, it can be anything from 0 up to n minus 1. When n equals 2, 2 minus 1 is 1. That means we have the 2s sublevel and the 2p sublevel. For 2s, L equals 0, which means that M sub L equals 0. The 2s orbital is spherical, just like the 1s orbital. For 2p, however, L equals 1, which means there are 3 M sub L values, -1, 0, and 1. That means there are 3 p orbitals. In xyz coordinates, where the vertical axis is z, the horizontal axis that's flat in the screen is y, and the horizontal axis that's coming towards you is x, we can say that these p orbitals are along the z-axis, along the y-axis, and along the x-axis. 1 each, 3 axes, 3 orbitals. Here's a pz orbital. Note it has 2 lobes. And the nucleus is in the center, where that red dot is. Now you'll notice that one of the lobes is shaded and the other lobe is not. That's just phase. The shaded lobe is negative phase, and the unshaded lobe is positive phase. Don't worry about that for now. Here's a py orbital. Just like the pz orbital, but rotated 90 degrees. And here's a px orbital. Forgive my terrible perspective drawing. Coming out at you. Electron density along the x-axis. 2 lobes. Just like the py orbital, but rotated 90 degrees. One thing to mention about a 2s orbital, it's spherical like a 1s, but it is larger in size than the 1s orbital. When n equals 3, we have 3 possible L values. 0, 1, and 2. n equals 3, L equals 0 is the 3s orbital, just like a 2s orbital, but bigger. n equals 3, L equals 1 is the 3p sublevel. There's 3 of them, px, py, and pz. They're just like the 2p orbitals, but they're bigger. L equals 3, n equals 3, L equals 2 is the 3d sublevel. Since L equals 3, the possible since L equals 2, not 3, the possible m sub L values are negative 2, negative 1, 0, 1, and 2. That means that there are 5 d orbitals. And here they are. There's the dxz orbital, which has its electron density sort of bisecting the xz axes. This is the line z equals x. This is the line z equals negative x. So it's in the xz plane. The dxy orbital is in the xy plane. This is the line y equals x. This is the line y equals negative x. The dyz orbital is in the yz plane. This is the line z equals y, and this is the line z equals negative y. We also have the dz squared orbital, which is like a p orbital with a donut in the center along the z-axis, and the dx squared minus y squared orbital. That's like having a py orbital and a px orbital superimposed. When n equals 4, we have L equals 0, 1, 2, and 3. The 4s, the 4p, the 4d. 4s is just like 3s but bigger. 4p is just like 3p but bigger. 4d is just like 3d but bigger. But n equals 4, L equals 3. This is the 4f sublevel. And now we have 7 m sub L values. Negative 3, negative 2, negative 1, 0, 1, 2, and 3. This means that there are 7 f orbitals, and they are a nightmare to draw. Let me see if I can find a good picture on the interwebs. And here are the 7 f orbitals. I'm not even going to try to designate which one is which.